Hello everyone, welcome back to my channel. So yesterday we spoke a little bit about arrays. I was very excited because we're getting to more complicated things. And arrays are groups of variables containing values of the same type. And we said there were two different ways to talk about the variables within an array. One was elements or components. I'm going to use elements from now on to refer to it, but I will remind you that there is another word called components for this as well. Arrays are objects, so they're considered reference types, and typically think of an array is actually a reference to an array object in memory. So elements can be both primitive or reference type within an array and refer to a particular element. Then the name of a reference of an array and the position number is how you access it. The position number is called the element's index or subscript. I will use index from now on to describe it, but you can also use subscript. And there is an array access expression, which is your name, and then your square brackets, open and close square brackets. And the first element has an index of 0. That is really important. It's the 0th element. Otherwise it will be out of bounds if you're iterating through and you have less than or equal to 10, for instance, when it should just be less than. An index should be non-negative, and also each array object knows its own length, and that's really important as well, because today we're going to look at another way to initialize an array, and knowing its own length is very important. And then you access it with the access creation expression and the array access expression, and then there's the array creation expression, which is the type and number of elements. Now the number of elements obviously then goes with knowing how many are in the array. We did it explicitly yesterday because we said int square bracket open and closed new array is equal to new int open and close square brackets with 10 in it. So we knew that there was an index of 0 to 9. Today we're going to do something else. I will also keep reminding you of different things that we've learned so far. So we learned the last in first out, and that was popping off from a stack and pushing onto a stack, and that was called, used our plates to show this in a previous video. And an entry on the top is called the stack frame or the activation record. I'm going to use stack frame. And then it has a return address, and it always returns back to the caller. Your local variables go away when you're finished with the method, so it's not there anymore. And your memory is reserved just for the local variables in the method stack frame. The stack frame is only exists as the method is active. That's also really important. So that's another data structure that we already spoke about previously, and a certain amount of memory stores these activation records or stack frames on the method call stack, and more method call there. If there are more method calls than there are activation records or stack frames stored, then you get a stack overflow, and actually the error can be caused by an infinite recursion. So I'm going to pause the video now and then write out the piece of code. It's only one line, and show you in a minute. It'll be a new way to initialize an array, and you do not use the new keyword, so it's a different way to do it. Okay, so I'm going to pause it now. Hello, so we have our initial our array initializer here. So what this does is it creates a new array, but without using the new keyword. It's a comma separated list, so you already know what elements are going to be in the array and the length of it. And that's really important because it's a compilation error if you want to modify the length after initialization. So one of the things here is that we have a list here with a comma separated list. The array already knows its length. This is really important because when it comes to the for loop down here, we have the initial counter is 0, and you can see here that we're using the counter as the number for the index as well. So we start the counter from 0 because the index starts at 0 because it's 0 based counting. So the first is actually 0, 1, 2, in the index. But the value of the array is 10. So we have 10 in the array, but the index starts at 0. 10 elements start at 0. So it goes from 0 to 9. So we have index 0, value 32, 1 through 9, and then 37 at the end. And here you can see here, when we're reading it, we have int, and then we know it's an array because the square brackets. The name of the array, we don't need to use a new keyword, and then just the list. This is called an initialiser list. These are all the elements within the initialiser list. It's called array. You can use it, you can call it something else if you want. I've just called it array. And then we print out our with our string placeholders here and here. We have 8 for the spacing and a new line, and that's just going to be index and value. We have our for loop here, which it has int counter is equal to 0, so it goes from 0, less than the array length. That's also really important because it's also another error. It would be an out of bounds error if you have it as less than or equal to, because it doesn't go to 10, it just goes to 9 for the index. So counter 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is going to be less than the length, which is 10. So 10 elements or components, as some might say, and then 0 to 9 index or 0 to 9 subscript. And then the counter increments through the loop the number of times that are less than the array length. And because the array is an object, we already know its length, and then we just print out using the %d for integers, and we put in the counter value within the array here for the value here goes into the array, so into the counter is associated with down here. So you can see here index 0, value 32. So that will be index is the heading, counter is going to be 0, and then array, what's going to be put into the array for each index, it's referring to 32, so I'm going to take 32. If I wanted to refer to a specific index, if I just wanted to print out the second or third element, I would just use this and have, let's say, 2. And that will be 0, 1, 2. So that's your third element. So it should be 64. So that's also worth noting with this when it comes to printing out anything or doing anything like that. Obviously we only need 1%d for that then, and if I ran that, it should come up at the bottom. Yeah, 64. So we have 0, 1, 2, and then 64, which is the third element, which is up here, accessible with the number, and it has to be a non-negative number. It has to be from 0 to the length of the array, and then it will be an out of bounds error if the for loop is going to be less than or equal to. Now there's a different type of for loop that we can use that we're going to use later on, but that's it for now. Okay, thanks for watching. The next video is also going to do arrays. We're going to stick with this for a little while. It's very important to get your head around because we want computers to do things multiple times, calculate things multiple times, and obviously as well we're going to make our programs a little bit more efficient and get our head around a lot of the memory and how it works and improve performance, which is also one of the top principles of software engineering. Okay, thanks for watching, and let me know what you think. If you have any questions, send them to learncomputerswithali@gmail.com, and looking forward to posting a new video soon. Okay, thanks.